Our next discussion about active galaxies involves another subset of active galaxies, radio galaxies. And radio galaxies, they also discovered back about the time that Seifert was talking about active galaxies. Now, at the time, they didn't think about Seifert galaxies as active galaxies. They were just thinking that these weird sort of spiral galaxies with bright cores. Radio galaxies, in fact, were discovered even prior to that. They were discovered all the way back when Groth-Reber first was scanning the sky with his radio telescope in Chicago, and he discovered that in the direction of constellation Cygnus, there was something giving off radio sources. Now, his radio telescope was not accurate enough in position to say where in Cygnus it was, just somewhere in Cygnus. So that was called Cygnus A because it was the first radio source discovered in Cygnus. Later, after World War II, Cambridge scanned the sky, made a catalog. The third Cambridge catalog, 3C, and this was object number 405 in the list, so 3C 405. Cygnus A. Bada and Minkowski were able, after the war, to figure out that the Cygnus A turned out to be the location of a rather weird little galaxy here that was kind of odd looking. It didn't seem to fit normal sort of parameters. And it was a pretty big redshift, 0.056. Remember, redshift is related to how far something is away from us. The redshift, Z, is the change in wavelength over the wavelength, what it should be. And so this is actually relatively far away compared to a lot of the other galaxies at that time. Okay, that makes it somewhere in the neighborhood about 230 million parsecs away. Well, with radio telescopes coming along, eventually the Very Large Array is able to look at this and find out that the radio sources are not really coming from the heart of the galaxy itself, but from these giant lobes of gas that got spit out by the galaxy in the distant past. And so these giant blobs of gas in two different directions. Well, what does that sound like? Well, we've talked about that. We have accretion, we have stuff falling in and stuff spewing out in two directions, these bipolar jets. And so what's this made out of? Well, hydrogen. So it's mostly interstellar medium type stuff that was being accreted and spewed out. Accreted into what? Well, it's being spewed out really far, so that suggests something of a huge amount of gravity. That huge amount of gravity would likely be a black hole. In fact, there's a whole bunch of galaxies that we collectively call radio galaxies. Most of the radio galaxies, actually the radio waves don't come from the heart of the galaxy, but from these giant lobes. So sometimes they're called radio lobe galaxies. And so here we have a galaxy Cygnus A. Again, that's a radio source. Cygnus in the constellation Cygnus is the first one, A. What you see in the light color, the light color middle, that's an optical image. The orange is actually superimposed on that. That's a radio telescope image of the same thing. And again, you see it's coming from these big jets that got spewed out away from the galaxy. And again, these radio lobe sources, we have a central galaxy and we have the jets that spew out, and where the jets kind of slow down in the intergalactic medium, they bunch up, and then that's where the gas is concentrating, and that's where you actually see the radio images coming from. Okay, again, we have multiple sorts of these things. This is a weird one right here, Centaurus A, NGC 5128. And when you look at it, it looks like pretty much an elliptical galaxy, except has a dust lane in it. And ellipticals aren't supposed to have a dust lane. So what's going on? What we see is the nucleus actually in radio waves actually has lobes. It's called Centaurus A because this galaxy is one of these radio galaxies. In this case, the lobes are actually pretty close in with it. So the lobes would actually be inside the rest of the galaxy, still on the way out. And X-ray telescope shows these jets going all the way down to this tight little core in there. So what's this telling us? Well, what we think happened is that this is maybe a merger of an elliptical galaxy with a spiral galaxy, because we've got this spiral sort of structure in here. We've got obviously what looks like an elliptical galaxy right here, but we have this spiral sort of structure of dust, gas, and so forth. And so, almost certainly, this is a merger, and there are stars forming in it, which normally doesn't happen in an elliptical galaxy too. So it's a starburst galaxy. So depending on who you ask, it's sometimes classified as an E0 peculiar because there's that dust lane in it, or an S0 peculiar because it's actually got more elliptical properties. And so at any rate, it's kind of a bizarre sort of thing. It's about 4 million parsecs away from us. That's 13 million light years. Some galaxies are moving very fast through space, and so the jets spewing out are being dragged behind by passage through the intergalactic medium. Again, this is NGC 1265, and is another one of these rather bizarre sort of radio galaxies. It's bizarre in the shape of the lobes here. The lobes being just, instead of straight out, bent back to the big lobes are back here behind the galaxy itself. Back to Cygnus A. This is like the stereotypical. This is one of the studied, well studied galaxies here, and they found that it too contains an awful lot of emission lines, more emission than absorption. And so again, it's kind of an odd one. Hubble telescope looking at the radio galaxies. When we look in the again, we keep seeing the same sort of thing. We have a radio galaxy here. We've got the galaxy. We've got these jets coming out. The Hubble telescope looking at the core, seeing a ring of stuff orbiting something very, very tiny. That tiny little thing there is so bright because you've got a lot of stuff accreting right into it right now. We can measure the velocity of the gas going around and find, again, we got millions of solar masses. So again, what we're finding here is, in almost all certainty, these radio galaxies are really the result of gas accreting into a supermassive black hole. Being supermassive, enormous amount of gravity, so the gas spiraling into there has these jets that go way out farther than they would with a normal accretion process. And so that's kind of what we think is going on. Again, radio galaxy M84, we got jets coming out of there, but the Hubble telescope looking in very, very close to the core actually sees one side very, very blue shifted, the other side very, very red shifted. So again, what you have is gas going around at super high velocity, supermassive black hole. A lot of Cygnus A, back to Cygnus A. We keep going back to Cygnus A because one of the first ones. And again, it looks like it's actually a collision of a bigger galaxy and a smaller galaxy running into it. And quite possibly the gases of these galaxies are disrupting what normally would have been going around the supermassive black hole, that parts of the small galaxy, the satellite galaxy, are feeding gas into that supermassive black hole, which is causing all the accretion that makes the huge jets that are coming out.